Hello everyone, my name is Jose Rodriguez. Welcome to the first video of our playlist dedicated to the operating system credential dumping LSASS memory technique. Before we continue, it is important for you to understand that the steps you will see in this video are just for educational demonstration purposes. You must not use them against any real network. The LSASS memory technique has been used by real adversaries to access credential material stored in the process memory of the local security authority subsystem service, or LSASS. We will use 3 virtual machines from our lab environment to simulate this attack: a Windows 10 system, a pfSense router, and a Kali Linux machine. If you would like to build a similar lab environment, please check the My Virtual Lab Environment using VirtualBox playlist of videos in the Open Threat Research YouTube channel. Here you can see a list of the tactics and techniques that we will show in this video. It is important to note that to simplify the privilege escalation step in our plan, we will execute the malicious payload or file as an administrator. Okay? The most important technique within this plan is LSASS memory, and we will implement it using the Kiwi module for Metasploit and the logonpasswords command. Here you can see our 3 virtual machines: Kali Linux, pfSense, and Windows 10. It is important to note that the interaction between Kali and the Windows 10 system will be through the virtual router. Okay? Okay, so let's start with the first two techniques to make our payload available for our victim, Stevie Marie. Let's start by using our Kali VM in full screen mode. Okay, let me change this to full screen mode, then access Kali. And I will also change this virtual machine to full screen mode. Okay, we'll log on into Stevie Marie's computer. So let me organize this better. Okay, so here's the PowerPoint. We have our Kali VM here, and here's our Windows 10. Okay. Okay, so let's start by using our Kali VM. Okay, and we will open a terminal window, and we will click here. Let me increase the font size for you. Okay, and the first thing that we need to do is we will change our current user to the root user. Okay, so we will run sudo space su, hit enter, and then insert the password for Kali. Okay. Okay, so we need to start by getting network information. Okay, and we will run the IP space A command so we can get the IP address for our Kali Linux system, which is 10.0.5.13. Okay, now we need to create a payload. Okay, and so we need to create a folder to store this payload. Okay, and we will create one folder under the home Kali directory. So we will use mkdir, okay, space home slash Kali slash, and the name for this new folder will be fake website. Okay, and then hit enter. Now, we need to create our payload and store it in this directory, okay? And we will use MSF Venom, okay? The dash p parameter for payload, okay? And the type of payload that we will use is a Windows slash x64 slash meter printer slash reverse underscore HTTPS, okay? We need to specify the listening host for this payload. We'll use lhost equals and then the IP address for Kali 0513. And we also need to specify a listening port. Okay, in this case, since we are using a web server to host this payload, we will use 8080. Okay, you can use whatever listening port you want. And then finally, we need to specify the format of this payload, and we will use the -f parameter. There are different type of formats that you can use. I will use an executable, and then we need to send this file to the fake website directory. So we'll use home Kali fake website. Okay, and then we need to specify also the name. And I will go with window x64 underscore payload. Okay, dot exe. Okay, and then we will just hit enter. This payload, once executed, will start a reverse shell from Stevie's computer to our Kali system. Okay, that's the main purpose of creating this malicious payload. Okay, so now that we have our payload, we need to make it available in a Python web server. Okay, and we will need to change our directory to the fake website folder, and we will use the cd command for that. Home Kali fake website. Okay, and if you use the ls space -al, you will see that the payload file is there. Okay, so we will use the Python command. Okay, the parameter -m and then http.server. Okay, space. If you want, you can specify a port. I will use the default, which is 80 for web servers. Okay. If we go to our Windows 10 system, okay, and if we open a browser, and if we go to the Kali Linux IP and 0513, okay, since the web server is using the default port 80 for web servers, we don't need to specify the port. We just hit enter, and we should have access to all the files within the fake website directory. And here's the link to download the payload. Okay. As we mentioned it before, once the payload is executed, a reverse shell connection will be received by our Kali system. However, in order to handle that connection and start a MetaPreter session, we need to configure a listener on port 8080, the same port we use when creating the payload. We will use the Metasploit framework to configure this listener. Let's open a new terminal window in our Kali system. Okay, so let's go to the second window of our desktop and then click on the terminal application icon. Okay, so let me increase the font size for you. Now let's change to the root user again, sudo su, and then the password for Kali. And then before we start the Metasploit framework, there are two steps recommended. Two steps that are recommended. The first one is to start the PostgreSQL service. that will help us to manage the Metasploit database. And also we need to start the Metasploit database using the msfdb command. Okay, so let's type systemctl, and then let's check first the status of the service, PostgreSQL. As you can see, it's loaded, but it is inactive, so we need to start it. So let's use systemctl space start PostgreSQL. And if we check the status again, it is now loaded and active. Okay, so now let's start the Metasploit database, and we will use msfdb space init, so we can create a database for the Metasploit framework. Okay, and now finally we can use the msf console command to start Metasploit. If you want to start Metasploit in quiet mode, so you don't get the welcome message with some information about Metasploit, you can just run msf console space -q for quiet. Okay, so let's wait for Kali to start the Metasploit framework. Okay, it's ready. So in order to configure our listener, we will use the multi-handler module. Okay, so we will run use space multi/handler. Okay, and then you can use the show space options commands to see information more, to get more information about the multi-handler module. And as you can see, it's using a default payload. Okay, we need to define a listening host and a listening port. Okay, these three values, okay, they should match the information we use when creating our malicious payload. So what we are going to do is use the set command to define the payload, the listening host, and the listening port. So let's use set payload, and then we will use Windows slash x64 slash meter preader slash reverse underscore HTTPS. Okay, let's define the listening host to 10.05.13, which is the IP of our Kali Linux machine. And then let's set the listening port to 8080. Okay, and we can start our listener by just using the run command. Hit enter. Okay, so as you can see here now, Kali is listening on port 8080, just waiting for the payload to be executed. Okay, so let's continue with the second tactic of our simulation plan, which is execution. Okay, so we need to download and execute the file and make the user execute this malicious payload, but as an administrator. Okay, so we will go here to our Windows system. Here is the link for the malicious payload. Let's just click on it so we can download the payload. Okay, the download is complete, so we can open this file in the folder, in this case the downloads folder, and we will execute it, making right click on it, then select the Run as Administrator option. And since Stevie Marie is not part of the domain admin or administrator groups, we will need to provide the credentials for a domain administrator account. In our case, we will use pedro.gustavo. Let me type here pedro.gustavo. Password. Okay. Once the file is executed, let's go back to our Kali system and wait for the creation of a Metasploit session. Okay, we just got the connection from our Windows, from our victim machine. As you can see here, the IP for the connection, the source IP for that connection is 10.055. That's the IP address of our router. Okay, remember we said at the beginning, all the communication is going to be through the router because the router is the device that is allowing the communication between the pandalab.com domain and the internet network. Okay, perfect. So now that we got initial access to our victim machine, okay, we can start our the discovery phase of our plan. Okay, so let's start by opening a shell. Okay, on the target victim. So we can start running commands. We can get information of the victim system by running system info. Okay. You can get information about the operating system, for example. Is a Windows 10 machine. Here is the version. You also have information about the domain. This computer is added to the pandalab.com domain. These are the hotfixes that were installed. And we have some information about the network card. And this is the IP address within pandalab.com for this computer, 192.168.141. Okay, so this is the, let's call it the internal IP address for pandalab.com. Okay, now we can get context of the current user by running who am I. Okay, and we'll also add another command so we can run two commands together. Who am I? And then specify the groups for this user. So we are running under, let me reduce the size a little bit here. Okay, so we are running this Metasploit session under under pedro.gustavo, and this user is part of the domain admins group in within pandalab.com. Okay, which means that we can access the system with high privileges. Okay, now we can get context of processes that are running in this computer. Okay, by using the task list utility. Okay, but if we go back to our plan a little bit, okay, at the end we will need to use the logon passwords function. Okay, and this function requires you to access the system um, using the system account privileges. Okay, so at some point we will need to escalate our privileges, and then we will need to migrate to a different process. Okay, that is more likely to access LSASS. Okay, so we need to identify in this process discovery stage, we need to identify processes or services that might be less suspicious of accessing LSASS. Okay, So let's go back here and we will run task list. Okay. We will specify the output format to table, and then we want the service information for these processes. And then we will add a filter because we want all the processes where the username is equal to the NT authority backslash system. Okay, so this query needs to be between quotation marks. And we got this list of processes. Okay, so all of them are running under the NT authority system account. Okay, so we have, here is LSASS, we have SBC host hosting multiple services. Okay, so we can just pick one. Like for example, you could use this one, the SBC host process 1400. Okay, that is hosting the user manager service. Okay, another option could be, for example, Sysmon, right? Sysmon is a security tool that usually access LSASS2 for authentication and security related issues or tasks. Okay, so that's 2620. So you can just, I'll pick a process and service randomly, but you need to be careful when selecting your process and service, because you need to be sure that the service or process that you are using um, is likely to access LSASS in your normal environment. Okay, so I will just take note of that process ID 1400 for SBC host. Perfect. So we have completed the discovery phase of our plan. Since we are using the logon passwords Mimikatz function, as I mentioned it before, we need to run commands under the system account. Then, therefore, we will need to elevate our privileges from admin to system. Okay, that's the next step for our plan. So we will use the access token duplication function within the get system module to elevate our privileges. So let's exit this shell. Okay, just by typing exit and then hit enter. And we will need to put our meter session in the background by running background. Okay. Remember the session number. Okay. We were working on session number 1. Okay. We will use that in future steps. So let's access the get system module by running use and then host slash windows slash escalate slash get system. Okay, and then we will use the info command, okay, to get more details about this module. As you can see, we need to specify the session and the technique that we will use. You have 6 options, as you can see here, okay, to try to get system privileges. Okay, we will use the second one, token duplication. So let's set the session first. Set session space. We will use number 1 because that's the number of session uh, for our meter previous session. And then let's use set technique, and we will use number 2. Okay. So now we can execute the module by running the run command. So if everything goes well here, we will successfully get system privileges. Yes. So the execution of the command was successful. Now let's interact with our meter previous session again, and we will use the sessions dash I space dash I space and the number of session, in this case number 1. And if we use the get UID command, we will see that we are running under the context of the authority system account. Okay, so we were able to elevate our privileges from admin to system. Okay, now before we jump into the credential access phase of our simulation plan, we will migrate to a process that is more likely to access LSASS, right? As we mentioned it before. This will make the detection process more interesting, okay? Because if we use our current process, the payload process, it might be more suspicious, right? So we will use the metaprever command migrate to inject our malicious payload to another process. So we can execute commands under the context of this new process. And we will use the process with process ID 1400. Okay, that's the process ID that we got from our discovery phase. So I will use migrate and then the number of the process, which is 1400. Okay. Okay, so the migration was successful. Okay. Um, we are now under the context of the SVC host process that is hosting the service user manager. Okay, great. So we finally got to the last stage of our simulation, credential access, and we will use the logonpasswords function to access the LSASS memory content. Okay, so what we need to do here is we need to load the Kiwi module. So we will type load space Kiwi. Okay, so we can load the Mimikatz extension for Metasploit. Okay, now we will use the Kiwi underscore CMD command to run the logon password function. So we need to do secure LSA colon and then logon passwords. Okay, and let's just hit enter. Once the command is executed, you should be able to see credentials material such as usernames and hashes. So if we go all the way up, for example, you have hashes and hashes for Pedro Adol Gustavo. Okay, from from the cache interactive for session 1, you can even see the password for Pedro Gustavo, like the clear text password. And we should also get information about Stevie Marie here. So this is the primary user for this computer. So we also got the hashes for Stevie. Okay. Remember that the data for this simulation will be stored under the Security Datasets project from Open Threat Research, and we will share the links in the description of this video. Thank you for watching this video.